Today we are looking at transforming formulas. You all know what transforming means, right? Like if you use something for something else or give it a different use. For example, sometimes I use a chair as a step stool. Sometimes I use a desk in class to sit on. And these things were used as a torture mechanism before they were transformed into eyelash curlers. Just kidding. But you get the idea. We use tools for multiple purposes, depending on our need. Same thing in math. We can take a formula that's used to find one thing and transform it to find something else. Let's take a look. The formula for area is length times width. But what if we don't need the area? What if we have the area and we actually need to find the width? Then what do? Well, we transform this equation by solving for width, or W. And how do we do that? The same way that we solve for x in a regular equation. So in this case, length times width, that's a multiplication problem, right? So how do we cancel out the L? We divide by L on both sides. Okay, and L divided by L is just 1, as we know, and that cancels. So now we have area over length is equal to width, and that's our formula to find the width. Let's say we have the area, we don't have the length, but we have the width, so we need to solve for length. How do we do that? Well, again, length times width, multiplication problem. Opposite operation is division. So all we're doing is dividing by the W on both sides so that we get A divided by W, or area divided by width, is equal to the length. And now we have 3 different equations, all from 1. Area equals length times width actually gives us width and length equations. Cool, right? Okay, so let's solve for S here. We need to get S by itself, which means that we need to work away from it. And away from it is the C. And we have a minus C, and the opposite operation of minus is, you know, plus C. And whatever we do to one side, we have to do to the other. So now we have C plus P is equal to S. Now let's solve for K in the equation H equals K over J. So how do we cancel the J? If it's easier, we can look at it like this. H is equal to K times 1 over J. And now we multiply by the reciprocal, J over 1, right? Remember how these two cancel? When you're trying to cancel a fraction, you multiply by the reciprocal. But whatever we do to one side, we have to do to the other. So we have to multiply the other side by J over 1, which is the same as J. So now we have J times H is equal to K. Another way to look at this, to solve for K, is to simply multiply by the denominator. So the denominator here is J, so we're just going to multiply the whole thing by J, because it's the same as J over 1, and we're going to multiply this side by J. So now we have J times H is equal to K, exactly what we got up here. Hopefully you recognize this equation. It's the equation for perimeter. Perimeter is equal to 2 times the length plus 2 times the width. So if you look at, let's say this is a garden, your perimeter, which is the measure of the whole outside, right, is 2 times the length, so 1, 2, right, because there's 2 lengths, and 2 times the widths, because there's 2 widths. That's how we get that formula. So let's say that we want to solve for L. How do we do that? Well, if we're solving for L, we know that we first need to work away from it. So we need to move this 2w because it's kind of in the way, right? But we can't just move the 2 by itself, and we can't just move the w because they're attached to each other. They're a package deal. So what we have to do is we have to subtract the whole thing, okay? The whole thing. So we have plus 2w, and the opposite operation of plus is minus. So we are subtracting the whole thing, minus 2w. And whatever we do to one side, we have to do to the other. So on the other side, we are also subtracting 2w. So now we have p minus 2w is equal to 2l. Are you with me? Okay, we're pretty close, right? We have 2l, but we need to still get l by itself. How do we do that? Well, 2 times l is really a multiplication, right? So the opposite of multiplication is division. So what we're going to do is we are going to divide by 2 on both sides. 2 divided by 2 is 1, which is perfect. We have 1l left on one side, and now we have p minus 2w is equal to l. Now we can write this a few different ways. We can write L is equal to P minus 2W over 2, which is exactly how we solved it. Or we can break it up, so because remember the denominator is the denominator for each of the parts P and 2W. So we can break it up as L is equal to P over 2 minus 2 over 2 W, which would simplify to P over 2 minus W, because 2 over 2 is just 1, right? So that cancels to 1W or W. Okay, don't freak out. I know that there are 2 variables, but it's going to be okay. So we are going to solve for A, which is in the pinkish reddish, right? So because we have 2 variables, we're going to end up with a variable in our answer, and that's okay. It's okay for A to equal to something times B or something plus B, because we don't know what B is, so we have to just leave it, and that is okay. So if we are solving for A, we need to work away from it first, right? Which means we need to get rid of the 7. Since it's plus 7, our opposite operation is minus 7, and whatever we do to one side, we have to do to the other. Now, B and negative 7 are not like terms. You can't add them, and you can't subtract them. So how we write this is very simple. 5A is equal to B minus 7. That's it. That's all you can do because we can't do anything else. So you just leave the minus 7 there. We are so close. We have 5 A's, but we only need 1. So our next move, as you know, since we know that 5A is a multiplication problem, and we know that the opposite operation of multiplication is division, we have to divide both sides by 5. Now, 5 divided by 5 is 1, and we're only left with 1A, which is exactly what we wanted. So we have A is equal to B minus 7 over 5. And again, we can split these up to write it in 2 separate parts. So we can also write it as A is equal to B over 5 minus 7 over 5. And it's the same thing as writing A is equal to B minus 7 over 5. It's really just up to your preference. So as you can see, we have a B, we have a variable in our answer, and that's okay. There's really nothing else we can do from here on out unless someone gives us the value of B, which we don't have, and so we're just going to leave it. This is the equation for A. All right, we're going on a road trip, a 425-mile road trip to Bryce Canyon National Park. You estimate that you'll average 50 miles per hour. To find out how long the trip will take, solve the distance formula, d equals rt for t. Then substitute to find the time. Okay, first of all, let's look at this distance formula. In the equation, d equals rt, r is the rate, so our rate is, in this case, how fast we're going, or how fast we'll average, so 50 miles per hour. And t is for time, so how long it will take us. Okay, and the d, of course, is our distance, which we already know is 425 miles. Okay, so since we're looking for how long the trip will take, we know that we're solving for t, right? Because we're looking for the time that the trip will take. We don't know. So first we need to solve our distance formula for t, which we know how to do, right? So if we have d is equal to rt, we know that this is a multiplication problem. And the opposite of multiplication is division. So we're going to divide both sides by r, right? And now we have d over r is equal to time. And now we can solve for t because we have our d, right, which is 425, and we have the rate, which is 50 miles per hour. So if we plug in our values, we get t is equal to 425 divided by 50. And t is equal to 8.5. So it's going to take 8.5 hours to complete our trip. So what we did here is we took the distance formula and we transformed it into a time formula. And since we're looking for the time of our road trip, how long it would take, we used the time formula and we plugged in the distance that we had, which was 425 for d, and we plugged in the rate, which was 50 miles per hour for r. So we had time is equal to 425 over 50. An exchange student in our class wants to know the Celsius equivalent of 77 degrees Fahrenheit. Use the formula F is equal to 9/5 C plus 32. So here we're given the Fahrenheit formula, but we need to know the degrees in Celsius, which means that we need to solve for, you guessed it, C. Okay, so we have to work away from our C, right? So we're going to work with 32 first. Since it's plus 32, the opposite operation would be minus. So we're going to subtract 32 from both sides. And now we have F minus 32 is equal to 9/5 C. And we are so close. We have one more fraction to get rid of, as you know, which is 9/5 because we need to get C by itself. So how do we do that? We multiply by the reciprocal. Yay! Now, this is where we see a lot of mistakes. 5/9 needs to be multiplied by everything on this side, which means that it needs to be multiplied by F and negative 32. So what we have is 5/9 times F minus 32 is equal to C, which is also the same as 5/9 F minus 32 times 5/9. All I did here was the rainbow method for distribution. So 5/9 times F and then 5/9 times negative 32. So now let's plug in our temperature of 77 degrees to figure out what the Celsius temperature is. C is equal to 5/9 times 77 minus 32. Now all we have to do is solve. We have 5/9 times 77 minus 32 is 45. So now we have 5/9 times 45, which is the same as 45 over 1. And we can cross multiply. 9 goes into 45 5 times. So now we have C is equal to 5 times 5, which is 25. So C is equal to 25. Try the problems below on your own, and you're solving for the variable in red. In case you're colorblind, the variable in problem number 1 is the W. In problem 2, you're solving for S. In problem 3, you're solving for S. And in problem 4, you're solving for A. You got this. Good luck. And don't forget to bring your problems with your work shown tomorrow to class for credit.